graphing these functions, we've got some PhDRV fun. So right now, PhDRV, I'm going to list that off. I'm going to do this one right here, PhDRV. I'm going to go ahead and write it for both, because why not? PhDRV, good times. My parent function is x squared quadratic. That means I am thinking that it is this up U shape. Horizontal shift. Words. I need to start slowing down my speech. Okay, horizontal shift. Inside moves side to side. I'm looking at the +3, but that means it's doing the opposite of what I expect, so I'm going to the left 3 units. My dilation is the number in front. I see a 0.5, which is good. That is less than 1. So I compress by 0.5. My reflection, I look for negative signs. I don't see any negative signs, so there is no reflection. And then finally a vertical shift down 2 because of that -2 on the outside. My horizontal shift and my vertical shift, left 3, down 2, means that my parabola, which would start at 0, 0, is now left 3, down 2, and is right there. I then need to figure out this compression. I know there's no reflection, so I know I'm opening up. And what I want to remind you is if I just had a normal parabola, 1, 2, 3, and I squared it, then I would go to 1, 4, and 9. But I'm not just squaring it, because technically I've got that 0.5 in front. And so when I apply that 0.5, I'm now at a half, at 2, and at 4.5. And so what this is saying is if I start at my vertex and I take one step left or right, I should go up half a space. So if I start at my vertex and I take one step to the right, I should go up half a space. And I'm going to put a dot right here. And I can do that on both sides. If I take 2 steps left or right, I'm going to go up 2 spaces. So I start at my vertex, I take 2 steps to the right, and now I'm going to go up 2 spaces. And I'm going to put a dot. I'm going to do that the same on left and on right. And then finally, if I take 3 steps to the left or the right, I'm going to go up 4.5 spaces. So 1, 2, 3 steps to the right, 1, 2, 3, 4.5 spaces. And you have an accurately drawn parabola that matches your equation. And obviously, you might not have to write this down every time. You want to be in the habit of writing this down just because it helps give me insight into how you're interpreting things. If you mix up the direction for your horizontal shift or you switch your horizontal and vertical shifts, I'll give you partial credit if I see this in between step versus if I just see a graph that's wrong. Taking that same information, I'm going to jump over to B. My parent function changes absolute value of x. That should be the reminder that I'm looking at that V shape. I now have no horizontal shift because there's no plus or minus inside of the parent function. I now have a dilation that is a stretch of 2. I have no reflection. My reflection would be a negative sign in front of everything or a negative sign in front of x. If it was a -2 in front, then that would be a reflection about the x-axis. And if that negative sign was in front of x, well then that's going to be a y-axis reflection, which you can't really think about because if you take a V shape and then flip it about the y-axis, it still looks like a V. But you get the basic idea. Finally, that vertical shift, I've got that +1 at the end, so up 1. I'm going to take my vertex right now. I start at 0, 0, but I need to go up 1 unit, so I do that. And then a normal absolute value graph would say, hey, I'm going to take steps of 1 over 1, 1 over 1, and I'm going to complete the parabola as such, or not parabola, absolute value as such, but now I've got the stretch of 2, so instead of going over 1, up 1, I need to go over 1, up 2. Over 1, up 2. And I'm going to do that on both sides. And I have my final graph for that absolute value.